Well, hello. Welcome to Doc Onco's Physics. My name is Keith Onco, and today what we're going to be looking at is another problem in one-dimensional kinematics, and this problem is also going to be in the y dimension. What we have is a ball which is going to be thrown straight upwards with an initial velocity of 12 meters per second. And we'd like to know what will be the height of the ball at its apex. So let's say I'm down here. I'm on the ground. Here I am, and I've got a ball here, and I'm going to throw it straight up. That's supposed to be straight. Ball is going to get to its apex, and then it's going to come, sort of straight down there. Okay, the apex is that maximum height to which the ball travels. Okay, so we know our initial velocity is 12 meters per second. So VI in the y direction is a positive 12 meters per second. All right, I'm throwing the ball up, right? And up we take to be generally positive y. So it's going to be a positive 12 meters per second. Okay. We want to know what the height of the ball is going to be at its apex. So I want to know x final in the y direction. Now, as is usually the case, what I do is, since my ball is leaving from my hands, right, I take my initial position of the ball to be 0. So xi in the y direction is 0. My initial position in the y direction is going to be 0. I'm trying to find out my final position in the y direction, okay? On the way up, of course. All right. Now, what's going to happen after that ball hits its apex? It's going to come back down. So only momentarily is this the final position of the ball. It's going to come back down to my hand where I initially let it go, but that's a different problem. So what's our acceleration going to be? Well, we're here on Earth. We're on the surface of the Earth. So our acceleration is going to be negative 9.8 meters per second squared. Okay. Do we know anything else about this? Well, we have our 12 meters per second initial velocity. Our initial position is 0. Our acceleration is negative 9.8 meters per second squared. How about the final velocity? Do we know the final velocity of the ball? Well, if we think about it, when the ball goes up, it hits the apex. Momentarily, what has to happen? Well, the ball has to stop, right? If the ball doesn't stop going up, well, I'm not at the apex. The definition of the apex is the highest height that the ball is going to go before it turns around and goes back down. So my final velocity in this case is going to be 0 meters per second. Okay? It's at the apex. It has stopped momentarily. All right, so can I figure out xfy now? Well, I think I've got enough information. I don't have time, but that's okay. Let's see if we can look at our equations and figure out what we can use. Well, first, I'm going to look at this equation, see if I can figure out xf that way. Well, I need to know my initial position, which I know, my initial velocity, which I know, my acceleration, which I know, but I don't have time. Could I get time? Yes, I could. I could use our second equation and get time that way, right? Because I know my final velocity, I know my initial velocity, and I know the acceleration. So I could get time that way and figure it out. But let's look at the fourth equation. I could also use this equation because, again, I know my final velocity, I know my initial velocity, I know the acceleration, and I'm looking for the displacement, the overall displacement. x0 is 0, right? So x final is really what I'm looking for. So either way would work. Let's use the fourth equation, all right? And I'm just going to draw a little line here because later on, I want to know how long the ball is going to be in the air, and we'll do those calculations on the left-hand side of the page. So V final squared, I'm going to use the fourth equation here. V final squared is 0, so 0 squared equals V initial squared. Well, that's going to be 12 meters per second squared plus 2 times A, which is negative 9.8 meters per second squared, times x final. Well, x final is what I'm looking for. All right, remember x initial is 0, so I just took that out of the equation. All right, well, let's move this to the other side and let's see what we get. So 12 times 12 is 144, so a negative 144 meters squared per second squared is equal to negative 19.6 meters per second squared times x final. All right. If I take each side and divide by negative 19.6, I'm going to get myself x final. And so x final turns out to be about 7.34 meters. Okay. And so we have our final height in the y dimension, all right, x final in the y dimension, I should put a little y there, it's going to be 7.34 meters. All right, now part B is a different question, and it's almost a whole different problem. Part B says, and I'm going to do these calculations over here and this square over here, how long will the ball be in the air from the moment it leaves the person's hand to when it returns to the person's hand? So in other words, I'm starting out here again, all right? I'll draw this line in a light blue here. All right, it's going to go up to this point here, and it's going to come back down to this point over here. So my table values are going to be a little bit different, and I'm going to draw my table values in blue to differentiate between the first problem that we did. Well, what's x initial in the y direction going to be? Well, it still starts out to be 0, so I'm going to put a 0 over there. What's x final in the y position? What is my final position in the y direction? Well, it started out here, got up to this point up here, and comes back down. It's at the same position. It's at where it started from. And so x final in the y direction is also 0. Okay? Acceleration is always going to be negative 9.8 meters per second squared. My initial velocity is still 12 meters per second, all right? And I don't know my final velocity, right? Because I knew it up at the top here because it had to stop. When it gets down to the position where my hand is here, that ball is moving, and it's moving in the negative y direction. So it's got some velocity in the negative y direction, but I don't know what it is. All right? It's something. Remember, it's not the velocity after it hits my hand, right? After it hits my hand, you know, all kinds of things change. It's the velocity just that smidgen of time before it hits my hand. Okay? So, what do I know? I know xi in the y dimension, x final in the y dimension, acceleration and initial velocity. I'm trying to find the total time. Okay? Well, let's see. This equation here will help me get time, but I don't have the final velocity. Okay? The third equation, all right, has x final, which I have, x initial, which I have, v0, which I have, all right, initial velocity I have, and acceleration, which I have, right? So I can use the third equation to find out the total amount of time that the ball is in the air just prior to it coming back to my hand, all right? So x final, which is going to be 0, is equal to x initial, which is 0, plus v0 times t. Well, v0 is 12 meters per second times t plus a half times negative 9.8 meters per second squared times t squared. Okay? So what do we got? Well, let's see. I'm going to take this 12 and move it over to the other side here. So I've got negative 12 meters per second times t, put these in parentheses here, is equal to negative 4.9 meters per second squared times t squared. Well, what can I do? I can factor out a t here, so I'm going to get rid of that t and get rid of the squared term, and I have negative 12 meters per second is equal to negative 4.9 meters per second squared times t. If I divide each side by negative 4.9, I get t to be about 2.44 seconds total. And that is my total time from when I threw the ball up to where it comes back down to the level of my hand. That's the total amount of time that the ball was in the air. I hope that helps, and we'll see you next time.